Hello students, in this video I will go through exercise U5A01C, where we will be performing similarity transformations either on a grid or on a plane. Alright, the questions coming out of this assignment stems directly from the Envision text out of page 314 to 316. Question 1, what makes a transformation a similarity transformation? What is the relationship between a pre-image and the image resulting from a similarity transformation? So what makes a transformation a similarity transformation is that all the different side lengths remain proportional. All the angles remain the same. So side lengths remain proportional by the scale factor. So if we're transforming by a scale factor of 2, then all the side lengths in the image will be by a factor of 2 longer than the pre-image. Right? Side lengths remain proportional by the scale factor. Image is multiplied by scale factor. Or I should say pre-image is multiplied by a scale factor. The image will have all angles remain the same. The image will have all angles the same as the pre-image. Okay. Question 2. Error analysis. Reese described the similarity transformation that maps triangle ABC to triangle XYZ. What is Reese's error? So remember, the orientation matters greatly. So we're going ABC. So in this case here, we're going clockwise. And then here we have XYZ. We're also going clockwise. However, what is suggested is A corresponds with X, B corresponds with Y, and C corresponds with Z. But that clearly is not the case, because if we rotate this, let's say, if we rotate this over point B here, right, what will result from this is you're going to have something that looks like this. So can you see that once we rotate this and then perform a reflection and then a translation, then we'll end up over here? So one more time, if I reflect this over that line and then perform the translation, can you see that C corresponds with X, A corresponds with C, and B corresponds with C, and A corresponds with Y, right? So that's the error there. So ABC does not correspond with XYZ. Okay. Actually, make that reflect. There you go. All right. Question 5. What are the vertices of each image? So we're performing a composition of transformations where we are going to be dilating and then rotating by 90 degrees over the origin. So, okay. So when we're performing a composition of transformations, we're always moving from right to left. So we're doing the dilation first. And if we're dilating something over the origin, which by default, if the point of dilation is not specified, then it is by default over the origin. Same thing goes for a rotation. Here in this case, though, they went the extra step and is telling you what the point of rotation is. It's over the origin. So here, when we're dilating something over the origin by whatever factor, we always multiply that scale factor by all the x and y components of the coordinate. So first, I want to write a prime as the first transformation, which is the dilation. So we're going to end up with 2.5, comma 0.5. B prime will end up being negative 1.5, comma 2. C prime will end up being 0, comma 1. And D prime will end up being 2, comma 3. Then we're going to rotate something over 90 degrees. And if you recall, when we're rotating something over 90 degrees over the origin, let's say this is A comma B, 90 degrees would end up over here, which means the coordinates are going to be negative B, comma A. So we're going to take all of these. A double prime will end up being negative 0.5, comma 2.5. I'm running out of room, so give me a second here. So A double prime will end up negative 0.5, comma 2.5. B double prime will end up being negative 2, comma negative 1.5. C double prime will end up being negative 1, comma 0. And D double prime will end up being negative 3, comma 2. So this is my final answer after the composition of transformations. All right, moving on. Question 7, describe a similarity transformation that maps SQR to DEF. SQR to DEF. Okay, so SQR to DEF, if you notice, SQR is clockwise orientation and DEF is counterclockwise orientation. So that what that implies is there has to be a reflection, because reflections do not preserve orientation, if you recall. So we're going to reflect this. We're going to reflect this, and if you reflect SQR, we'll end up over here. And then we're going to perform a rotation. So there has to be a reflection, and then a rotation, and then translation. So a reflection. It's harder to specify reflection over what. So we're going to reflect over, let's call this L. Reflect over L. And then it's hard to specify a rotation of how much, though, right? Because there's no real measurement being offered here. But it's going to be a reflection, then a rotation, and then a translation of SQR. Again, because we're on a plane, it's difficult to numerically state what the translation is and what the rotation would be. However, just describing it would be sufficient. Okay, question number 8. Do the two figures appear to be similar? Use transformations to explain. So, do they appear to be similar? They actually do not, because the angle measures are actually not congruent. They don't appear to be congruent. So let's say if we reflected this GH, EFGH over the line GH, the reflection would not cause the orientation to be in the same manner. So all angles do not appear to correspond and do not appear to be congruent. And when I say appear, because there's no real measurement here, we can't really tell. And even as the question suggests, right, do the two figures appear? Right? There's no actual measurement here. They're asking us purely just to use our eyeballs to eyeball it. Okay. Question 10. Error analysis. Keegan was asked to graph triangle ABC through a composition and transformation dilating by 2 and then rotating by 90 degrees. So dilation of 2 and then rotating 90 degrees. So ABC, if we dilate by 2, ABC will end up over here. Remember, all the coordinates gets multiplied by 2, so B will end up at 2, 6. 2, 6 is right here. So it will end up like that. And then C will end up at 2, 8, which is like right there. Whoops. Okay, so this is going to be the intermediate step, and then afterwards, then when we rotate this, this is A, B, and C. When we rotate this, though oriented, the coordinates will not end up in the right places. So A, B, and C will end up just slightly off. So it looks like what happened is Keegan rotated and then dilated. So Keegan went in the opposite order. All right, moving on. In the diagram ABCD, A prime, B prime, C prime, D prime are the angle measures of, what are the angle measures of A prime, B prime, C prime, D prime? Okay, so they're telling us that the two shapes are similar. So if that's the case, ABCD, since I know that this is parallel, this is 80 degrees, this must be 100, this must be 80. And if that's 48 over there, then that means this is 65, no, 55. 55 plus 48, we end up with 103. Then that would be 77. And then this would be 77. And then the remaining angle would be 180 plus 77. That would be 257, leaving us with 23 as the angle. So if that's the case, then A prime will be 23 degrees. B prime will be 100 degrees. C prime will be 80 degrees. And D prime will be 77 degrees. Okay. What are the vertices of each image? So this is a composition of transformations. Notice that we're not given any axes here, because you really should learn how to graph this or try to solve this algebraically. And the algebraic manipulation is when we're dilating something by some factor over the origin, we're going to be multiplying that factor. We're going to be using that factor to multiply all the x and y coordinates. So if we do this, and by the way, if you're hearing huffing and puffing, that's my dog. So We're taking XYZ, we're multiplying 1.5 by 6, and that would be, actually I write it a little more over. So that would be 1.5 times 6, that would be 9. 1.5 times negative 2, that would be negative 3. Y prime, we multiply 1.5 by 4, and that would be 6. 1.5 by 1, that would be 1.5. Z, negative 2 times 1.5 is negative 3. 3 times 1.5 is 4.5. And by translating something, we're going to be actually adding that vector to each of the x and y components. So x double prime, the final transformation, we're going to take 9 and plus 5, that would be 14. We're going to take negative 4 and add it to negative 3, and that would be negative 7. And we're going to do the same thing with each of the coordinates. So 6 plus 5 is 11. 1.5 plus negative 4, that would be negative 2.5. And z double prime, negative 3 plus 5, that would be 2. And 4.5 plus negative 4, that would be 0.5. And there you have it. All right, question number 16. Same thing. We're going to take L prime. We're going to multiply each of the coordinates by 1/2, so it's going to be 1, 2. M prime. Again, each of the coordinates multiplied by 0.5, so it's 2, 2. N prime. Each of the coordinates multiplied by 0.5, so it's 2, negative 2. And P prime, that would be 1, negative 2. Next, we're going to reflect over the x-axis. And when we reflect something over the x-axis, remember the x-coordinates. Let me just do a quick reminder of what that is. When we're reflecting something over the x-axis, let's say a comma b, what will result from this, okay, is we're going to end up with a comma negative b. So this will become L double prime will be 1, negative 2. M double prime, 2, negative 2. N double prime, 2, positive 2. And P double prime is 1, positive 2. And that's it. Question 17. We have 3 composition of transformations here. So when we're rotating something, let me just go over the rule again, because I personally need to remind myself of what the rule is every time and again. And I hope that you guys will also take this on as the standard of practice. Let's say to always draw the picture out and then to recreate what the rule is for yourself in the event that you forget it. So when we're rotating something over 270 degrees, that's the same thing as rotating something over negative 90 degrees, and that would be a clockwise rotation of 90 degrees. What will end up happening is the coordinates, I want to make this a little more dramatic. Hold on a second. So let's say something like this. So this is a comma b. What will end up happening is this will end up being b comma negative a. And if writing it out in terms of these variables doesn't make much sense to you, write it out and give it some numbers. Let's say 2, 1. You can clearly see that in order for this to make sense, 1 would have to remain positive and 2 would have to be negative. Okay, so again, we're going from a comma b to b comma negative a. All right, so when we're reflecting or rotating something by 270 degrees, we're going to be using this formula here. So P will become 3 comma negative 1. Q will become 2 comma 4. R will become 5 comma 0. So that doesn't change. Okay, so when I say that doesn't change, I mean the 0 doesn't change, because 0 is neither positive nor negative. All right, p double prime. Okay, we're going to multiply those coordinates by a factor of 2. That would be 6 comma negative 2. Q double prime, that would be 4 comma 8. R double prime, that would be 10 comma 0. Lastly, we're going to have triple prime. When we're reflecting something over the y-axis, we're going to be negating the x coordinate and keeping the y coordinate the same. So this will be negative 6 comma negative 2. Q triple prime will be negative 4 comma 8. R triple prime will be negative 10 comma 0. So this is our final answer here. And the last question. Sorry that this video is becoming so long, but this will give you a sense that each of the homework assignments should be somewhere between 15 to 30 minutes. Okay, so we're reflecting something over the x-axis. So again, when we reflect something over the x-axis, we are going to be negating the y-coordinate. So this is 2 comma negative 6. B prime will become 0, 0, because 0 is neither positive nor negative. Mm-hmm. C prime will be negative 5 comma negative 8. And D prime will be negative 2 comma negative 10. All right, so that's A, B, C, D. And then we're going to be dilating by a factor of 0.25. So what will that get me? So that will get me A double prime will be, so 0.25 is the same thing as 1/4, so that's 0.5, comma negative 3/2, or negative 1.5. B double prime will be 0, 0. C double prime will be negative 1.25, comma negative 2. And D double prime, that will be negative 0.5, comma negative 2.5. And that's the final answer for that. And that's it.